G'day all, so we're going to be looking at this example today. So first, it's always important to highlight the information that is important to your question, or underline, take note of it. So for this question, use a solid line in the graph of Hubble's data to estimate the age of the universe. So this is the graph just below. So we need to estimate the age of the universe, and we're going to be using the graph below. And also, make sure in your answer you compare this with his estimate of 2 billion years. That's any comparison that you can make. Okay? So, sorry about that. Just getting something off my screen. So, with this, we first need to look at this graph and see if we can understand this. So, hopefully you notice that your distance is in parsecs down the bottom on the x-axis and velocities in kilometers per second. So this gives you a hint of what you actually need to do. First, you want to get your distance units the same. Okay, so you'll see velocities in kilometers per second, so the distance unit that's kilometers, while our distance on the bottom is in parsecs. So we need to convert from parsecs to seconds. Okay, but we just need to pick out some points on our graph first. So Hubble's constant that we use to find out the age of the universe, this is the gradient of the graph. So the gradient, we need 2 points. So I'm going to pick these points. First, you'll notice hopefully here, we start at 0, 0. So that's a really easy point to use and makes your calculations really easy. Okay, so it starts at 0, 0. It doesn't say 0 on this one, but you can see it's going up by 500 each time. So 500 to 1,000, so this one here will be 0. Okay, so that's another easy one. The other point we're going to use to find our gradient is this one here. Okay, it goes through the line. You could probably use this one in the middle here as well, either or. So this value here, I'm just going to write the x and y value. This is 2 by, sorry, my writing's still a bit sketchy on this, by 10 to the 6, and that's parsecs. And then our velocity is about 1,100, and that's our y value. So, what we first need to do is go from our parsecs to kilometers. Okay, that's the first part of this question that we need to work out. So this is our value of 2 by 10 to the 6, and we need to put this in kilometers. So to get from parsecs to meters, we multiply by 3.09 by 10 to the 16. But because we're going to kilometers, this will be 3.09 by 10 to the 13. So we just do 2 by 10, sorry, not 2 point, by 10 to the 6. And this is going to be multiplied by 3.09 by 10 to the 13. So just make sure you understand these conversions, okay? So here, we've got these here. So this here, this will then equal, and make sure you do it in your calculator to check, this will equal 6.2 by 10 to the 19 kilometers. Okay, so that's our new value. Okay, so that's our new x value, I should say. So now we need to figure out Hubble's constant. Okay, and Hubble's constant, this is the gradient of the graph. So remember, gradient of the graph is the change in y over the change in x. Okay, just remember that's what that little symbol there means, change. So y, this goes from 1,100, take away 0, okay, y2 minus y1, and then our x2 Just remember, don't use 2 by 10 to the 6. Use this value here, 6.2 by 10 to the 19. Okay. So once you do that calculation there, that should equal, and just make sure you have a bit of a look at the units. Our velocities in kilometers per second, and this is in kilometers. So we're actually going to be left with, in our answer, a unit of per second. Okay, so our answer is in the units of per second. So this here is 1.78 by 10 to the negative 17 per second. Okay, that's what the S negative one is, just the per second. That's our units. Okay, so now it says we need to estimate the age of the universe. So how it is estimated is we take the reciprocal of our Hubble's constant. So the time of the universe is equal to 1 over our big H, our Hubble's constant. So this here, 1 over 1.78 by 10 to the negative 17 per second. So this is going to change our units from per second to seconds. Okay, and now we have a time unit. So just make sure you're aware your units can give you a big hint of how to get it in the right units for your answer that you want. Okay, so this here, once you figure this out, our time value, this will be 5.62 by 10 to the 16 seconds. Now, we need to compare this with 2 billion years. So we need to get from seconds, and we need to go from seconds, and I'm just going to do this over here, to years. Okay, so just break it up. How many seconds in a minute? 60. And how many minutes in an hour? So another 60. How many hours in a day? 24. How many days in a year? Okay. So from seconds to years, remember you divide. So you get whatever your value of your seconds are, and then you divide it by all these multiplied together. Okay. So that's how you do it by hand. If you have a computer handy, you can use a converter, but it's also good just to make sure that you are practicing doing this on your calculator. So we do 5.62 by 10 to the 16 seconds divided by all of these numbers together. Remember, 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, and there's 365 days in a year. So that's where all those values came from. So this there will give you a value of around 1.8 by 10 to the 9 years. Okay, so this is around, well, it's 1.8 billion years, because 10 to the 9, that's a billion. Okay, so this is 1.8 billion years. So now we just need to state our answer. So our estimate, or what we worked it out, so the universe is 1.8 by 10 to the 9 years old. Okay, So, and we just need to compare this to his estimate of 2 billion years. So 1.8 by 10 to the 9 years old, this is actually 2 billion years to one significant figure. So it's consistent with Hubble's estimation. So this is consistent with Hubble's estimate. Of 2 billion years. As it is 2 billion years to one sig fig. The screen's just struggling because it was down the bottom. So this is how you actually go about answering these questions. Make sure you do have a little worded description at the end of your questions as well. This shows understanding of everything that is going on. So just make sure you are doing that. Alright? Sorry about the writing, it's slowly getting better. Alright? So just make sure that you do break down the question like this, that you highlight your question, you work out your points, okay? Make the right conversions. Alright? These are all integral skills which help us in physics and all sciences. Alright? So I hope this helped, and good luck.